In hands-on number 9 and hands-on number 10, we'll look into scripting. Use scripting if everything else fails. If there is no built-in function or any other way to achieve something, sometimes you have to resort to scripting, although in SV it should be quite rare. But here is one example of a behavior that you can't achieve without scripting. As we saw, all our randomly generated assets have the asset type set to equity. But this is not very realistic. Unfortunately, there is really no built-in function to randomly select out of a set of possible values. And that's why we'll use the JavaScript rule to populate this asset type field randomly. As the first step, we'll create a JavaScript rule called setType of randomly generated assets, which will randomly populate the asset type field for the randomly generated assets. Here is the code that we'll use and slightly change it for it to work. Just don't copy it from here. The same code can also be found in this file. Okay, to create a new JavaScript rule, you simply select this scripted rule. You can see we support two options. Either you will write in JavaScript or in C#. And the rule is, if you can, use C#. JavaScript may be a better known language, but C# will provide you more built-in libraries and it will always perform better, since JavaScript needs to be interpreted again and again based on the source code. But for C# we simply build a DLL and use it in background. But let's start with the JavaScript rule. And let's perhaps move it under the service call activity related rules. When you open it, you can see the initial content of the rule. We can safely delete it, and let's replace it with the content of our sample file. Data model scripting is only about populating data model values. So whatever you do here, you do because you want to populate some field in response mostly. And in order to be able to populate a field, you need to know how to access it. And that's fortunately very simple. You just right-click somewhere, click Insert Path, and here in this tree of fields, we'll select the structure we need to retrieve. In this case, we need to assign this assets variable with the assets array from response. So we'll select the structure, click Insert Path, and this is how you can access the assets array. So let me copy it out and put it here and with semicolon. So this is how to retrieve a value from the data model. You can also use autocompletion. Type hpsv.request suggested portfolio risk level. This is how you can get to the value in the risk level field. We could store it in some variable, then do something with it, and then update the value like this. We'll do something similar with the assets here. So we stored the value of the assets array in this assets variable, and now it's just plain coding. It's cycling over all the assets, and based on this randomly generated number, we set the type of the individual assets in that array to equity, bonds, ETF, or commodity. The fields in scripting have the same names that you can also see in the data model rules. But for JavaScript, the auto-completion capabilities are quite limited. When I press Ctrl space to invoke this set of auto-completion suggestions, you can see it is not very accurate. And that's because JavaScript is not a strongly typed language, so auto-completion will never be 100% accurate here. On the contrary, in C#, it will always be accurate, so that's another reason to use C#. So let me save the data model and restart simulation, and let's have a look how our script performs. So let's change the citizenship back to Spain. Press send. And as you can see, the randomly generated assets have now not just the type of equity, but also bonds and ETFs and so on. So we can go to our dashboard and test the implementation. Oh, and seems like we changed asset types also for the original sample data. Yeah, that is because this rule has too high priority. As you can see, also for the scripted rules, the rule priority matters. And since this rule is above the samples from documentation, it overrides the type field also from the imported samples, which is something we don't want. Basically, these scripted rules are just like the data model rules, except that you write script rather than assign functions. Let me put this JavaScript rule below the samples from documentation. And now let's restart simulation and click the dashboard again. Yeah, it doesn't complain now. When you write scripts in a C# rule, you have access to not just the data model fields, but also to the machine itself. For example, you can query some external database, or you can read files from file system. You can also work with third-party libraries, and so on. So C# in general is much more powerful, but not out of the box. Because when you deploy your services to the standalone SV server, by default, C# rules will run in a security mode. And in a security mode, the C# code will have access just to the data model structures, which is fine most of the time. But if you want to use file system or external databases, then you need to switch the security mode off. It will also substantially boost the performance. To learn how to switch the security mode off, follow the link in the description of this video. Okay, in this hands-on number 10, we will make use of this decimal type, which is available in C# but not available in JavaScript rule. And we'll fix a rounding bug that the portfolio suggestion service team introduced. The total value in USD is being calculated incorrectly since the team behind this portfolio suggestion service use a float number instead of a decimal number for adding up money values, which is incorrect. As the mitigation, we'll use a C# rule. We'll create a new C# rule to accurately calculate the total value in USD. In this script, we have two places to fill in, but again, don't use it from here. We'll use it from the sample file. Okay, so let's create a new C# rule. Let's call it calculate total. And inside it, again, we have the initial script content. But this time you can't remove it, because in C# you always need this class with the execute method. So you always write your code here inside the execute method. Okay, so let's start with a C# sample. And here we already know how to retrieve the assets array. So I'll right click, use the insert path functionality, select portfolio suggestion response type, and here I'll retrieve this assets array by clicking insert path. I always need to end with semicolon. That's the same like in JavaScript. And to store this total, we can use auto-completion, because in C# auto-completion is always accurate. So we'll need the response structures, the portfolio suggestion, and we'll fill it into total value in USD like this. When I click restart the simulation, we can check whether our changes took any effect. So originally the total value in USD was this 10,000. Now after clicking send, it should calculate to a different value. Yeah, like this. So let's test whether our C# rule is working correctly. And it is. Now, how to debug issues in scripting? We obviously support logging, so let's log something. Here in the JavaScript rule, let's uncomment this hpsv.logger.error line of code. So this is how to log an error. You can also log different things like info, warning, or debug information. The default log level can be set in the config file of the SV designer or the SV server. This line will log to the text log file of SV Designer or SV Server. So let's test it. Let's restart simulation, press send. And now let's look inside the SV Designer log file, which can be found here by clicking Open Designer log file. As you can see, this is the last message, and it's also the message that we logged as error from JavaScript logger. This is the ID of the virtual service. We also support a second way of logging. Login to the problem list, meaning to this section of the virtual service. When I uncomment this line, we will see an error in the message log. When I restart simulation and invoke that request again, you can see here on the virtual service homepage, this error showed up. After you resolve these errors, you can safely delete them so that they don't bug you anymore. Now, a couple of short remarks. So firstly, your virtual service should never end up as the second implementation of the real service. Create your virtual services as simple as possible with the minimal effort that is required to trick the client applications to thinking that they are communicating with the real service. And very often this only requires recording some basic traffic, ignoring a couple of columns and introducing a couple of copy from functions. You should also know what's the location of the text log file of the SV server or the SV designer. You can find these locations in the description of this video. Also notice we very often surround our script with such an if clause. This is to make sure that this portfolio suggestion structure is initialized at this moment with some values. Otherwise, the script would internally fail with null reference exception. The same construct can be seen here in our C# rule. To make it more likely that the structures inside will be initialized with some non-empty values, we also by default use this get or create functionality that will initialize this structure before you use it. And also, if you right-click the rule header and display properties, you can see that by default the scripted rule skips the first simulation pass. This means that when the script is executed, already the default rule has been executed and generated some default values. Also by default, we only execute the script once. You can edit these scripts in a new tab, or in case you have, for example, the JS file associated with some editor, you can use this option to edit the script in the JavaScript editor of your choice. For JavaScript, you can also insert shared scripts that you can store here. This is quite useful if you want to use some third-party JavaScript libraries. For a C# rule, if you want to use some third-party library, you can simply drop the DLL to the extensions folder of the SV Designer or the SV Server, specify the namespace here and start using the DLL. For more, follow the link in the description of this video. Sometimes C# rules can be quite a convenient way to speed up your virtual service. Imagine how much faster it is to generate a huge array using a simple C# script rather than recording such huge array to your data model possibly multiple times. If you have a huge data model, it will slow down your service. So for huge but simple structures, it's sometimes more convenient to generate them from a C# rule. And last but not least, if you have the Visual Studio installed, you can edit your C# scripts in Visual Studio. And that's quite handy. You'll just put a breakpoint here. You will attach your Visual Studio to the designer process. And now, when I invoke the request, the breakpoint will hit and you will see the values. You can step through the code, you can edit it, and so on. Just keep in mind, this approach only works if you work on the embedded server or if you have the Visual Studio installed on the same machine where the standalone server process is running, and in that case you need to attach your debugger to the standalone server process or set up some kind of remote debugging.